All right. So, good evening or morning, depending on where you are. My name is Savanna Box. I'm a recent graduate from Embry-Riddle Aeronautical University, and today presenting with me is Isabella Koss and Dr. Sean Kraus. We're going to be talking about climbing acceptance, how trip profile, capsule design, and training shape space elevator ridership intent. And I want to give a shout out to the students and faculty that couldn't be here with us tonight to present. And if you are interested in our previous study of what type of person is willing to ride in a space elevator, you can check out the ISEC 2024 proceedings page. Next slide. Cool. So for our overview, so to start, we're going to be talking about the background and why we want to put humans into the equation of space elevator travel. So then we'll move into our dependent variable, which is our willingness scale and the potential variables within this willingness on who would like to ride one. Our research questions and hypotheses will then tie into our method, design, and procedure, and I'll be kind of going over our survey and how it was conducted for our participants. And then we'll wrap up with our results discussion and summary. And now I'll pass it off to Isabel to talk about the lit review.
When we looked into the literature, technical research on space elevators advanced, but the human-focused studies lagged behind. There are even fewer studies on how passengers picture their journey, whether it being a visualization of a thrilling journey, scary journey, or even comfortable journey. Public trust builds slowly, just like when aviation transportation was introduced. They had to have years of proven safety, transparency, and clear communication. So it's reasonable to anticipate trust within 2 decades for the space elevator as that is as well. For long-term support grows when framed as economically practical and environmentally stable. Next slide, please. For our dependent variable, we were looking at willingness, accepting by choice or without reluctancy. Past studies in other areas were looking at driverless cars, autonomous ambulances, school buses, and aviation. Those studies shows people's willingness depends on emotion, usability, familiarity, and complexity. Dr. Rice and Dr. Winter wanted to operationalize willingness, so they created the willingness to ride scale. Their research in 2020 showed that it is a highly reliable scale. Next slide, please. Our potential variables, first one to look at is our altitude and time, which go hand in hand. We had 4 tiers, 30 kilometers for 10 minutes, 100 kilometers for 3 hours, 6,500 kilometers for 22 hours, 35,786 kilometers for about 119 hours, which covers the range of a short to a multi-day journey. We then chose 3 cabin sizes, small, similar to the Gemini, medium, similar to the size of the Dragon capsule, and large, similar to the size of the Orion Crew module. We also were looking at suits. We compared pressurized suits versus no suits. Pressurized suits has safety, but restrictive, whereas no suits are comfortable, but less protection. And then lastly, we included training modeled after the programs like Blue Origin and NASTAR. Current spaceflight participants train for about 1 to 2 days, so we scaled slightly up from that to match the longer ride times. Training not only prepares passengers for emergencies, but we also hypothesize it will help reduce anxiety and build willingness to participate. Next slide, please.
Cool. So moving into our research questions and hypotheses. So our hypotheses covered our mission profiles, capsule size, training days, and suit conditions, all that Isabel just listed in the previous slide. And our 5th hypothesis was non-directional given the complexity of the higher order effects, and all null hypotheses are assumed. Next slide. All right, so the purpose of our study, this current study, is to assess a consumer's willingness to ride based on the factors we just listed. So altitude and time, size of the capsule, whether a pressure suit is worn or not, and the length of training. For our method, we used a quantitative experimental design. So this included a 4x3 by 2x3 ANOVA. And for our population and sample size, so we had 534 participants, and across our participants, the average age was 42.58 years old. And our demographic percentages are listed here below. Next slide, please. Moving into our procedures. So similar to our last study, we used Prolific, which is an online survey platform similar to Amazon MTurk, if you are familiar. So, but basically, Prolific is better than Amazon MTurk because we're able to screen our participants so that we're getting reliable data within our sample size. So we used a Google form and exported that into Prolific. Once they verified that they were 18 years or older, then they were shown a generalized space elevator description. From there, they were randomized into their 4 conditions. So this is the between subjects aspect of the ANOVA that I mentioned before. After they're randomized, they're given a description based off of their respective conditions. So there's an example of this below. And all descriptions included the travel time, the distance, and what they could expect at each altitude. So this includes like their scenery and gravity effects. After this, it moved into 18 randomized scenarios. So this is our willingness scale, and this includes all the variables that we've listed. So then it moved into and concluded with our demographic questions, debrief, pay, and dismissal. And so now I'll be giving it to Dr. Kraus to talk about our results.
All right, so I'm going to start a little backwards than you normally see ANOVAs presented and start with the interactions because as you can see, we had 4 significant interactions in these, size and training, size and suit, training and suit, and then size, training and days for a 1 3-way interaction. But if we look at the effect sizes, 2 of them are, all 3 of them are really small effect sizes. So when we plotted these out on graphs, it is very hard to visualize these. So we just wanted to present this as an F table to kind of describe some of the interactions. And then this is one of those areas, while they may be statistically significant, they're from a practical sense, they're very hard to actually observe and kind of understand, especially as we start getting into the more complex 3-way interactions. There was no significant 4-way interaction between the 4 items, however. So I'm going to go over the main effects now. So for the between subjects, which was the 4 categories, there was a significant main effect for altitude and time with a small effect size. And for the post hoc analysis on this one, the only significant ones was from the lowest altitude, the 30 kilometers, 10 minutes, to the highest altitude at geosynchronous at 119 hours. So, with that, kind of see that, well, there is a significant main effect, it only is between the 2 items. However, the other items that we found, we had a significant main effect for all these other ones. So this is for the capsule size. From small, medium to large. This one was a 0.14 8 squared. So that's considered a medium or large effect size, depending on which literature that we cite on this one. And the pairwise comparison with the Bufferoni corrections after for post hoc showed there was willingness significantly different among all capsule sizes, with it large being the most willing. One thing I want to point out on these charts, though, is that if you notice, it is a scale from +3 to -3, with 0 being not, with very, sorry, +3 is extremely willing and -3 is extremely unwilling. No, there was only one small category that actually gained a positive rating for any of these ride scenarios. Every other one was a negative one. However, the willingness did increase as these different components started to increase. So the large capsules, of course, being the most willing to ride in. For the training days, it had a very similar one. And if you look at the 2 graphs back to back, I'll put it back and forth, but they're almost identical. The effect size on this one was 0.13, so a little bit more. And for this one, the same thing on the post hoc. All the interactions, so 1 to 2, 2 to 3, and 1 to 3, were all statistically significantly different. So that shows as training increases, so does their willingness to ride. The last one and the largest effect size that we got was the significant of suit. So with a suit, they were much more willing to ride than without a suit. And this one had a 0.25 eta squared, so very high percent of the variance explained with just the suit. So putting all this together, in order to affect size, wearing the suit, the size of the capsules, the amount of training influence willingness to ride. The suit condition was much higher with than without. So that kind of shows that people may be seeing this as a sense of protection and perceived safety in suits. It could be from the media always depicting everyone in space in some sort of space suit, or they might have some knowledge. Personally, we did not gauge familiarity with spacesuits or familiarity with space travel in this one, so that could be another indicator that we could look at in the future. Capsule size, of course, was large, medium, and small, with all significant pairwise. So again, when we go to the larger capsule, it's more comfortable, more spatial. They're not as confined during these long journeys. So this, really highlights that the actual environment is going to shape their willingness during these activities as we start moving into commercialization of these. For training days, it increased steadily from 1 to 3. So again, more exposure, more familiarity, reduce the uncertainties that the people had, which would increase their willingness. And then the shortest trip was greater than the longer trip. So they wanted the low and medium duration trips rather than the long one. The longer the trip, it decreased their willingness to actually ride in the space elevator. And then the interaction effects that we look at, the size and suit. So the suit was benefit. The biggest effect that we saw there was the suit benefit was greatest in larger capsules. So the larger, more spacious area plus the suit gave people probably some sort of more sense of security and more willingness to ride. The days and suit grew stronger with training. So that could highlight the fact, we did not give them a full definition of what the training would entail, but they most likely assume that the training includes getting into the suit, getting with the suit, which would increase their familiarity with the suit. And then the size of the capsule and the days of training also increased willingness as well. And then the three-way interaction that we had was the size, days, and suits. So the highest willingness was with a large capsule in a pressure suit with 3 days of training. And that one actually peaked at a 0.12 positive, the only positive interaction that we had out of all 18 scenarios. So really provides a lot of evidence that the physical design factors, as well as different experimental factors, will shape the willingness to ride. More research really needs to be done on this as we start moving into this. But this was one of the, this is only the second human factor study that we've done for the Space Elevator Consortium. So I'm sure there's plenty more that we can move to next year and years beyond to kind of, hopefully get the profiles down for who's going to be riding in these elevators before we move to it. So with that, I'll pass it back to Savanna.
Cool. So in summary, we found in this study, and I would also argue our previous study, that public trust in space elevator depends on mostly safety, communication, and alignment with societal priorities from the users and participants. And this kind of goes into the next bullet of being influenced by emotion, safety perception, familiarity, and comfort. Those are big things that we saw in our previous study as well, that kind of tied into our lit review for shaping this study. So in this one specifically, as mentioned, we tested altitude and time, capsule size, pressure suit, and training length. And then our results, so our largest or biggest impactful interaction was with suits, larger capsules, and more training, and participants or users also preferred shorter trips. And this can suggest that design and experimental factors together can help shape the perception of users for space elevator travel. Next slide, please. And I want to give a quick thank you to Embry-Riddle Aeronautical University and ISEC for their continued support in our research endeavors. And are there any questions? I see Jim has a question.
Yes, I think your survey may have lacked one aspect, and that's the motivation for the people to get on the elevator. like, it seemed like it was just for the purpose of the ride, but there wouldn't have been a motivation, say like, you're invited to the Academy Awards thing, all expenses paid, but it's going to be at, you know, these different altitudes. What, would you be motivated to get on the elevator given these other parameters and that? So without the motivation of a destination or what they're going to go, there isn't the carrot at the end of the stick, so to speak.
Yeah, and well, I completely agree with you on that. That would be for a different type of study to see what motivates people to actually travel on a space elevator rather than the different conditions that they would ride. So everybody got this, what I have highlighted here, as a kind of a primer of what space elevators are, to give them a kind of, this is, generated from a lot of the space ISEC literature, or not space ISEC, the Space Elevator Consortium literature. So we kind of use that plus the example descriptions. And then as we moved larger, we did the calculations to show like what the effective gravity was going to be at every different condition as well. So that was the motivation that they received, was just the example description, not like, hey, you're going to go up here for an award show or something. We
Yeah.
could possibly do future studies where we give them, you're going up there to, meet a celebrity, going up there to do XYZ, and then look for interaction effects amongst that to kind of see what actually, intrinsically motivates someone. But yeah.
Mhm.
Yeah, and I'll add that our previous study, our scenario focused more on like greener space and leaving a smaller carbon footprint. And one of our feedback points was that our scenario might not be realistic enough. So for this study, we tried to focus more on broader and keep it a little bit more accurate. Kind of, against the point of giving them too big of a carrot to launch onto,
Yeah.
and then given the different conditions.
Well,
The
well,
study specifically.
I'm concerned that if you're doing this survey for airlines, for example, and you were saying you're going to go on a 22-hour airplane ride in, coach or, business or first class, but one destination is New Zealand and the other destination is Wake Island, you'll get different answers for the different destinations, because the Wake Island, there's essentially nothing to do unless maybe you're into scuba diving or something like that.
Yeah,
So
and that's why we made these very general and didn't put very specific things as to
uh,
what they'd be doing there. We just said they'd go up in the elevator, get some time, and then come back down.
yeah, okay, thank you.
Yep.
Other questions, please? I think it's pretty clear we have to establish a party bus.
Absolutely. That was, I like this image right here of the party
Oh,
bus
yeah,
going
yeah.
up.
Yeah. Oh, Stephen's got a question. Okay.
Yeah, I think that some of the discussion I was listening to was, I believe in the motivation, but are you there to live, work, or just visit? And
Yeah.
one would be, I think you have to start looking at it as, if you believe it's a risky thing, then how much more would you have to be paid to go work, or paid to go out there and settle space, or, like I said, I've heard other people talk about the motivation. It's not just the motivation, it's if it's like your job is up there, then what kind of compensation do you need? And to me, that's more of a comparison between the safety issues and the differences between rockets and a space elevator. If your intent is to go, or if you're forced to go, then which one would you prefer? Should it be more of a preference thing versus that's all your option? Your only
Yeah.
option is a space elevator.
And that's something that we can do for our next study, is actually compare human spaceflight by using, like a Falcon 9 that's highly reliable versus a space elevator, and put some assumptions in there that it's just as reliable as the Falcon 9 and kind of see what people would do at that point with those different types of vehicles.
This was reliable as Starship.
Yeah.
Maybe not,
All
maybe
right.
not that reliable.
Savanna, Isabel, Sean, thank you very much.